Share screen. So everyone can see my screen and can hear me well?
Yep.
Hi everyone, and joining. Welcome to our September session of the Digital Twin Hub Meets. And just a bit of few housekeeping rules. In addition to these, actually, I'll just get everyone to put in their full name and dash their sort of organization if they can. That would be good. And cameras are optional. Please mute yourself when you're talking, and the session will be recorded and it'll be on our Digital Twin TV on YouTube. If you have any questions during the presentation, you can put it in the chat box, or otherwise you can just wait till the questions at the end and raise your hand and ask the question. Just a quick sort of note about Smart Cities Week. So Smart Cities Week has been moved to February next year and it's still happening in Melbourne. Most probably it will happen in Swinburne University. And we're just getting confirmation on the final dates, but it's looking like it will be the week of 6th to the 10th of Feb. If you have any questions regarding the speakers, program, sponsorships, attendance, anything, feel free to either email me on LinkedIn, message me on LinkedIn or email me or give me a call. I'll put in my email in the chat box in a sec as well. And just the draft program, there's more information on our website as well. And yeah, if there's anything, just let us know when we get back to you. I'm just going to pass it on to Robin as well, and she will give a bit of an update on the challenge and a couple of other programs. Robin?
Sure. Hello, everybody. I haven't joined one of these in a while. So if I haven't met you, my name is Robin Francis. I sit in the global team, essentially coordinating engagement across all of our locations. So quick update from us, the Digital Twin Challenge, we have a catch up on the 12th of October. So we're looking forward to getting together and seeing everyone's progress, and we're on track to present at Smart Cities Week. We are going to be sending out expression of interest forms to our members and I guess broader network as well over the next week and a half to run through the task forces that we have planned for 2023. Digital twin is absolutely still a focus area for us, specifically as it relates to data. So keep an eye out for that. And if you feel that there's something that we're not covering that's pertinent, critical conversation point for you, let us know and we'll make sure it's given enough attention. And then, yeah, I just wanted to touch on some of the amazing work being done in the digital twin space. Collaboration is a very big focus for us, especially in the coming year. So we're looking forward to the launch of the Digital Twin Partnership at the beginning of October. And if you haven't been listening to the episodes of Digital Build Australia podcast, I recommend having a listen in there. And just on the podcast, we do have our own Smart Cities Chronicles. So if you're interested in being on an episode, we have a cybersecurity one coming up soon. Reach out and we can book you in for a chat. That's all from me.
Cool. Thanks, Robin. And in terms of our presentation today, the topic will be visualization and digital twins. And our speaker is Sam Clark, who's the head of business development at Reveal from New Zealand. And just over to you, Sam. I'm just going to stop sharing so you can share your screen.
Awesome. Thank you very much. Let me pull that up. There you go. So, hey everyone, my name is Sam Clark. So I'm the head of business development at Reveal. We are a subsurface utility engineering software company / field mapping company based in New Zealand. So we've got about 55 or so staff in New Zealand, dotted around the place, who are all working to improve our understanding of the underground, basically. So yeah, so we've been operating for about 10 years. We started out as utility locators, the people that you'd call up to come out onto a site and use GPR or EML, electromagnetics, to find things in the underground, mainly utilities. So we started out by putting paint on the ground to show, the engineers or the project contractors where the stuff was, and from there we started to create plans for people and PDFs, and then from PDFs we went to web maps, and then we've sort of found our way into the digital twin space as it's sort of evolved over time. So yeah, so today I'm here to show you sort of, in particular, the visualization piece. So with the underground, it's all unknown, it's all buried. So the visualization becomes a really key piece of, I guess, the end delivery solution for subsurface digital twin solutions. I'll try keep it really focused on visualization, but if you've got more open-ended questions around what we do, hold them to the end, and I'll be happy to answer them either online or offline. So the underground is, as many of you will know if you've worked in construction, is a huge pain in the ass, basically. The information that we've got that describes and represents the underground is varied. Some of it's correct, some of it's inaccurate, but in general, it's typically quite unreliable. We find that typically there's about 40% of extra things in the underground that don't exist on existing plans and records. And so what this means for society is, the most immediate one is we have huge amounts of utility strikes. In New Zealand, we had 12,000 reported utility strikes last year, and all this adds up to a huge amounts of disruption. So when you get these things on projects, and you get massive amounts of project delays and poor design, you get, when they use inaccurate information at the front end of design and planning for projects or asset management, you get suboptimal decisions. And you also get lots and lots and lots of repetition in the industry around people spending a lot of time and effort to go out to find the things in the underground to then only, one of their counterparts do the same activity, 3 minutes later. This is in New Zealand anyway, and what we've seen overseas is sort of pretty commonplace for the level of information that you can get for existing records. So this is the chorus plan for Britomart, one of Auckland's major train stations. And this is when you put in a request to find out what's in the underground through the before you dig process. This is the current plan that you get. And it's up to the end user to then kind of decipher this, understand where the risk is, understand what's important, what's not important, and then include that in your decision-making process to then what usually means you have to go out into the field and reconfirm the location of everything. So what we're doing at Reveal is we're going out and we're trying to fix the problem. So we've got 10 years of expertise in the subsurface mapping space. And so we're combining a bit of our scalable technology solution with proactive field mapping. So we're going out into cities and we are creating a comprehensive database of the underground using a mixture of different techniques. So that's towable, ground penetrating radar, electromagnetics, opening chambers, gaining access to existing information, a whole heap of different things where we pull all of the available information together into one platform. The difficult part, which is where it kind of links into today's presentation, is how you make sense of it. Not everyone can look at 100 different files that all kind of represent the state of the underground and make the best decision off that. So what we do is we can bring all that information into our data model. We then process that information and we revisualize that as synthetic aggregates, or these a new visual feature to which we can then hang off all sorts of valuable information and insights and sensing technologies off the back end. So this is kind of what the current state of the market is. When you kind of go online and you look for underground utility information, it's points and lines and polygons, and most of it's in 2D. A lot of it, there hasn't been a great consistent record of capturing depth, and so because of that, everything is kind of defaulted to 2D, which is fine for some planning purposes, but for others, the three-dimensional sort of capability is really, really key. So as I said, we go out and we map cities. So the first sort of city that we've just most recently mapped is in Wellington. So we've done, I think, 38 hectares so far of road corridor and footpath. So this is the utility corridor where most of the utilities exist, except for maybe the gravity stuff. But in terms of the density, it's where a lot of it is. And we have created a kind of an independent 3D visual platform which shows the location of all this sort of stuff. While we were there, we also found all sorts of other things. There's not just utilities, and so that's why we like to consider what we do sort of subsurface digital twins rather than a utility digital twin, because we find things like buried tram tracks, areas of reinforced concrete, lots and lots of unknown assets that you don't really know what they are until you dig them up. Voids, leaks, all sorts of things. And so kind of the picture that we take is very much subsurface. I'll run into this when I jump into the twin. I'm going to be risky and go straight into the prototype. But as I said, what we do is we bring it all together into a centralized platform to which we can then serve it up in a rich 3D environment. Now we've built a web viewer which enables people to be able to view and interrogate this through their, through a web interface, which is super handy for some people. But we're mindful that most of the application for this sort of rich level of information is in design, and so we're working to expose this same level of sort of rich visual granularity into things like AutoCAD and Revit and other design software, so that people can fast and effectively undertake their design work. Yeah, so what I might do now is I might jump into the twin. Oh. So bear with me a second. So I hope everyone can see that. So this is Wellington. So as I said, we've gone out and we've mapped over 35 hectares. So most of the main road corridor, which falls under the Let's Get Wellington Moving project. So these are areas where we've got huge amounts of upcoming capital works undergoing in the city. And so everything you see here, let me turn on the 3D, is an outcome of our mapping work. So none of this is existing records. This is all through, as I said, ground penetrating radar, LiDAR scans, point clouds, photogrammetric models, electromagnetics. Because with the underground space, it's kind of different to, I guess, building a digital twin of a manufacturing facility or a library or a building where you can kind of go in, you can do an initial scan and build your base model, and then you're kind of up and running. With the underground space, because everything is buried, you kind of need to be able to pull together any information that you can get your hands on and pull it together into a centralized place to which you can then build upon. And so some things may be incorrect, but until you're kind of proven otherwise, it's the best information you've got. And so the kind of the ecosystem that we've built allows for that iteration over time, and that's kind of the digital twin concept that we've got. It's quite different to I guess the digital twin, the representation of the virtual representation of reality is really the more of a probabilistic model of what potentially could be in the underground. So it's yeah, a little bit complicated, but this is kind of what you see here. We base all of our standards on PAS 128, which is an international UK standard for utility mapping, and we do that primarily to then align the information that we've got with an accuracy level. So if I jump over to here, what you'll see is you've got purple is comms, red is sewer, orange is gas, yellow is electricity. And so this is all an outcome of ground penetrating radar and electromagnetics. Now it's all got an associated tolerance of error. So if you now interrogate these various records, you can then go into the accuracy, and we start to visualize what that tolerance of error is associated with that in specific record. And so that that tolerance of error comes out of the PAS 128. So we're sort of aligned internationally as to what people can expect. And so sort of for the first time, you can start to understand not only where something is in the underground, but the probability that it may not exactly be where it is being represented. And then you can also then dive into all of the evidence. So, well, how was this found? And so if it was a LiDAR scan that created this thing, or a manhole inspection, or a GPR, then you can drill down through our data heritage model and actually pull out those specific records. So depending on who you are, you can start to make really, really, really fast and effective decisions. And so here's a great example where we've got we've gone ahead and radared the street, and then we've now got a photogrammetric model that's come in, which is using our as-builting tool to capture some new comms network being laid down in the underground space. Now, when they've done this, they've now exposed this gas pipe here. You can just see to the left. So when we detected it using the ground penetrating radar, we thought it was approximately here. Now that we've exposed it, it's actually to the left by about 5 centimeters. And so now it's definitely within our tolerance of error that we had there. But now we can come into our model and we can adjust that record across, and we can then include and improve the accuracy of at least this section of that pipe, so that it's got a much smaller tolerance of error sort of threshold. And so using, with the underground, you kind of need to, the virtual representation comes as you get all these different bits of information. And so once we've done our initial sort of scan of the city, we can then allow people to bring in additional information about the underground and build upon it until there becomes a point in time where this is so comprehensive and accurate that you can start to make very different decisions than what we currently do in the underground space. So yeah, I think that is kind of my 10 minutes up. So I may leave it there and then dive into some questions depending on which direction people are kind of keen on going into. I'm mindful I didn't go into too much detail around the visualization exactly, other than it being 3D. I might just show you one more thing actually before I go in, which is the 360 imagery. We found this to be quite eye-opening, I think. Something as simple as having alongside your sort of 3D records, the actual input, the 3D 360 image that shows you actually how this thing was derived, provides a whole heap more context over and above, especially like a condition score rating. Suddenly, if you were an operations engineer and you need to attend an emergency service request for this comms pit, you can jump in and you can quickly understand that there's no access ladder and it's partially submerged, and so that you can start to drive some real safety outcomes. But yeah, so I mean, this is what we're doing. So we've started with Wellington, we're moving up to Auckland now, and we've got a couple of POCs that we're looking at signing up over in Australia and in the US. But pretty soon we hope to have sort of this level of information available in most of your major cities across the Western world, at least, for people to start to consume and use for different purposes. So yeah, really keen on seeing any of your questions. Cheers.
Thanks, Chris. That was great. There's been a few questions from the chat. So the first question was from Derek, who asked, what do the colors represent? And I think as he asked it, you sort of answered this a couple of minutes after, which I think is the different utility services. Is that correct? Or
yeah, that's correct. Sorry, that's when you work in this space, you sort of glaze over some of the things. But yeah, so the green stormwater, red's wastewater, purple's comms. The interesting thing is the pink stuff that you see is unknown. So these are things that we've detected that don't exist on any plans, or potentially there are things that are on plans, but in such a vastly the wrong location that you can't correlate it to anything. And as I said before, we found about 40% of everything that we sort of find in the underground space is classified as an unknown, which is that pink.
And the next question was from Brahma, who asked what software was used for the reveal twin map.
Yeah, so the view that I'm using here is built into ArcGIS Online. We host our data in Azure and ArcGIS Online and a few other things, depending on the file format. But the actual viewer that we use is currently ArcGIS. And as I said, this web viewer that we've built is more of like a landing page for people to be able to use on the fly, with the intent that a lot of the actual use case of the data actually exists probably on other platforms like AutoCAD solutions, or on people's or customers or asset owners' own GIS platforms themselves. So we've tried to, the file formats that we've developed on are all based on international standards, and the data schema that we've used Muddy, which is an international schema for the underground. So we've tried to keep things really standard so that it can be used by a broader group of people as possible.
No worries. And I think then Chris Buddy from Canberra had a question that Derek answered, but it was about, I think you mentioned the standard. Could you repeat or put it in the chat? And Derek mentioned that it was the PAS 128. Yep.
Yeah, so it's kind of a hybrid, to be honest. So we use bits from the PAS 128 and a little bit from the Australian standard. They've kind of got their strengths, but in terms of the accuracy and how we map, because in the underground you can't specify what level of accuracy that you need. You kind of specify what level of methodology that you'd like people to undertake. And depending on their findings, then you get a certain level of accuracy, because different ground conditions can produce you different results. And so that's quite a really smart way of kind of articulating the accuracy. So the work that you can see, you can kind of understand what level of effort has gone into deriving that insight. And then depending on that level of effort, then you get an associated level of accuracy based on various studies. And so you can start to build kind of workflow off that based on these international standards, rather than it just being a guessing exercise.
And a question from Gabby. Is the web app constructed using a GIS app or bespoke?
Yep, so the viewer is ArcGIS Online, and then the everything that wraps around it is our own sort of custom stack, and we house the data on our own stack as well.
Cool, thanks. And another question from Derek, which I think is actually a great question. How's the work being funded, and what are the approaches to maintaining a sustainable operational funding model?
Yeah, so at the beginning of our journey, we were contracted by Let's Get Wellington Moving, which is a large infrastructure project, to go and do a large area of utility. Well, initially it was to pull together all the existing records, and so we did that, and then we found a whole heap of errors, and so then we went on to the first phase, which was to undertake some mapping. They only wanted a certain level of detail, and we felt that it was potentially a missed opportunity to not capture everything we could while we were there. So we kind of went above and beyond and captured all sorts of additional things. So we laser scanned every chamber at our own cost, and we 360 image things, and we did a bunch of additional work with their support, but definitely at our own cost, to sort of get the model to where it was. We're now working with Wellington City, and they're sort of our first pilot customers, who are Wellington City are really keen at taking a leadership role in fixing this problem for their city, because they've got such a burning platform with all this infrastructure work coming up. And so what they're looking at doing is essentially being our one customer, where they support the maintenance of this model going forward. We provide the mechanism, so as new information gets found out about the underground, so it could be someone digging a hole and using our app to create a photogrammetric model, or it could be a survey output from an as-built. It can all get uploaded into our platform, and the underlying 3D model then gets updated over time. And that's kind of the service that we're looking at providing. So they'll be the customer. They provide the data to essentially whoever they please, which is probably going to be anyone who wants to use it for good. And then we provide the service, which is, the hard bit, which is around the maintenance of that data model. And this 3D viewer is definitely part of it. But we're on, whilst we've been around for 10 years, we're sort of 18 months into our technology journey. So we're looking at, partnering with customers at the moment who can help us learn and develop our products, so that we've got something that's even scalable and fit for purpose for a broad range of people. So with that mindset, we're sort of working very collaboratively with them at the moment.
And just a quick question from me, following from Derek's question. So would ideally, as you, I guess, scan a city, would it sort of look like that you wouldn't have to redo the scan every once in a while, because you would sort of rely on the new things being uploaded onto your system? Is that
pretty much? So that's sort of the commercial model that we're testing. So we have a bet that we can go out and we can undertake an initial, high level of mapping and create, kind of like the foundational level model that can then be built upon. But as long as there's the tools and there's the desire from that industry to, continuously feed in information, then we don't envisage that we'd need to go back and do at least as a wide scale mapping. So there are alternatives to that. We could look at, linking back in and doing just ultra wideband radar and finding any areas where there's been, a difference, and we can then do targeted detections. We're not too sure. There's a couple of different models we're looking at, but ideally we would sort of set up the initial model, and then the cities, whether it's the contractors or the engineers, could then provide information, and it would kind of improve over time rather than kind of go the opposite direction. So yeah, that's the high level commercial model, and what we're trialing in Auckland is how we can do this commercially without any support of the cities or from the asset owners. And so whilst it's quite cost prohibitive to create this level of detail, this is kind of what we consider the platinum version of the model. We do have automated techniques that we've developed for visualizing essentially raw data. So we can go out and we can map the whole of Auckland for, pretty cost effectively, feed up a kind of what we're calling an underground point cloud, which is kind of, it represents the high intensity readings. And then people can then access that and request data processing on demand. So there's a couple of different options for how we can deploy our subsurface twin, depending on the appetite for the customer, whether it's a city or it's a project or even an asset owner. We've kind of got a couple of different flavors.
Yeah. And just another question from Gabby. How do the clients access the models? Is it just the web app, or is it copies of the files, or?
Yeah. So at the moment we can provide copies of the files in any which way or format. But because it's essentially a live model, providing static copies is kind of counter to what we're trying to achieve. And so we're developing an API so that you can have access to the live model and essentially subscribe to areas, so that if there's a change in that area that's critical for you, say you're a project engineer designing a new water main, then you can be notified if there's a change to your area that could be of concern to you. And so, yeah, as I said, we're looking at developing out some APIs at the moment. But we've just produced some stuff for augmented reality, which I think is the area that we think has the most value from sort of this level of detail of data. There's lots of people focusing on building the front end platform for augmented reality and VR, but when you try to apply it in real world context, the data is just not quite accurate, and so you can't seem to use it that well. And so we see this as being that bridging solution where we can finally have workable, as long as you know where you are in the world. The positioning bit's a little bit difficult, but as long as you know where you are in the world, then the accurate information should help you, understand and contextualize the underground space in a way which hasn't previously been done.
Thanks. And a good question actually from Belinda, who has asked, have you tried mapping tree roots as part of the underground ecology?
It's about what you look for. So I don't think we've looked for tree roots. We've used it for things like finding graves, finding extensive, underground, closed landfills. So, it's end of the day, kind of what we've used to create this is geophysics. And so you can use a different range of geophysical techniques to find kind of whatever you're targeting. And so I'm sure there probably has been people that have used a mixture to look for tree roots. Yeah, we were looking for real high intensity detections, which inferred that there was something of importance there, generally something with a large structure. So not in this model, but potentially it could be an application.
No worries. And question from Scott from McDonald. Are you working with utilities to bring in the data directly rather than via Delve Before You Dig, or? Yeah,
so for Wellington, with Wellington City's support, we've got live access to most of the utilities GIS data. And so that kind of forms part of that solution. And there's a lot of cities across the world that are looking at undertaking those sort of initiatives at the moment, creating these federated databases where they can view all of the utility information in one place. So we've incorporated that into what we do. I haven't got it turned on, but show you real quick. But essentially here what you see is start to visualize all of the existing records. And so this is kind of the madness that you're looking at. And this poses a lot of the problem. Some of the stuff here that we know are, some asset owners have provided what looks to be schematics. So these aren't actually, geo accurate in terms of their location. They're kind of schematics that show the network connection of, who and what customers they service. And so it's not, if you didn't understand that context for some of this information, you'd think that there would be absolute spaghetti carnage in this corner here. It probably is spaghetti carnage, but probably not to this degree. So this is what we would consider one of the low-level entry kind of twins that we can produce is pulling together all that federated data in one place, and then building from it is the real key piece. Is how can you capture all those insights that can help those asset owners improve their records over time, and also not just lose those records that were used to derive that insight, but actually provide them in part of the solution so that you can gain access to it. And you know, a lot of the stuff is pulled together for projects, and projects have a fixed life cycle. And when you get to the end of the life cycle, the team disbands, and there should be a handover process, but it's not usually particularly transparent. And so, you know, you lose all this valuable information. And so a bit that we're trying to pull together is a kind of a decentralized place where you can just store all your things. And so as these projects, you know, work over and over again to improve our city and our connectedness, there's a home for all of this information that they can come back to.
And a question from Chris from Canberra again. The unknown utilities and objects, which I think was the purple lines.
Pink, yeah.
Yeah. Do you have any idea who owns them? Or
no. So if we knew what utility it was, then we would make that assumption, and we would say it's electrical, or it's a gas, or whatever it is. Because it's an unknown. It's not an unknown. Because it's an unknown, we don't know at all what type of utility it is. We could start, depending on the type of method used to detect it, you may know whether or not it's metallic, which may help. But in terms of knowing who it is, and especially when you're working in areas where you may have multiple asset owners of gas and multiple asset owners of electricity, it's very difficult. It's only where these detections kind of start to correlate with an above ground feature that you can 100% say is owned by Wellington Electricity in this example. And so anything that you can trace off this feature here, you can kind of say is probably Wellington Electricity's. But anything that doesn't correlate, like these records here, it's unknown until proven otherwise. And so that's the kind of value. So depending on what project you may have, you've got different levels of risk. And so if you were needing to, you know, excavate this footpath here to put in a new water main, and you dug up this whole street and you exposed all these unknowns, and you uploaded a photogrammetric model, we could then now know, you know, with a lot more certainty what these utilities are, as well as where they are. And so in that small area, you're not just improving the asset location for the asset that you were contracted to install, but you're actually improving the residual data for the city. And so it may be a Wellington Electricity contractor who's actually improving the location of a chorus comms duct, and vice versa. So you start to get this bit of a network effect with people improving everyone else's information.
A question from Derek, which I think you sort of mentioned on this, but in Australia we have dial before you dig, and he's asking if there's a similar organization in New Zealand that is used to find utility services. Do you also have in New Zealand, or?
Yeah, it's kind of different. So in Australia, they're non-profit organizations which are built up of a collective of members, which are usually the asset owners who support those organizations. In New Zealand, it's a service that's provided by one commercial entity. And so the guidance from the New Zealand government for WorkSafe is you must contact all the asset owners and gain access to all the existing records prior to excavating. They don't say that you must go to a specific thing. So there is one company that kind of provides that handshake as a service, but again, they only service about 70% of the utilities. So for the ones where they don't have members, then you've got to contact those people directly. And usually that's things like Three Waters, because they're publicly available. So it starts to get very confusing. And what we've created is not intended to replace that. You know, the process that you must follow to meet your obligations under things like WorkSafe and, you know, and safety obligations is a separate thing. We see the real value for what we do at the real front end of the asset life cycle. So in that operation, that asset management, that project feasibility and project design stage, where you have the opportunity to actually not just stop people from striking utilities, but actually design them away from harm. And so we see this as real supplementary to that dial before you dig service.
And a bit more of a, I guess, technical question from Hayden Wright from Mott McDonald, and he's saying, sorry if I missed this, but could you briefly talk to the options to export or link this to BIM software with ISO 19650 compliant content?
Yeah, so we're just working on that at the moment. It's some of our current sprints, and so we're working on how we can expose this information. And so our intention is to provide it through API. I know off the top of the head, some of the file formats that we've provided are things like SLPKs, which are a three-dimensional open source file type. But it's kind of going to be horses for courses. So for each of the different packages of software, we kind of need to be pretty fluid with how we serve it up. And so again, our intention is to be able to, as we engage with the market, understand customers' use cases and develop the most appropriate solution. So while we haven't got anything that's finalized, it's kind of the intention is for it to be open source and accessible and hopefully very easy to use.
Cool, thanks. And question from Simon Hunt. And is this for utilities only, or have you captured pavement and surfacing types and depths?
Mm-hmm. Yeah. So in this model you're looking at, we process the data to pull out all the utilities, any of the anomalies and voids, as well as reinforced concrete, because they pose specific pain in the ass to construction projects. But the next step, which we're just working on now, is we're going through and picking all of the pavements. And so what that means is you start to get a 3D visualization of the actual thickness of the pavement structure itself, as well as you can start to pick up any issues like delamination. And so we see that being potentially another stream of data which we can serve up to people who may be of interest to it. So we kind of view this very much as kind of like a data as a service bit. But you're 100% right, the pavement stuff it's exactly the same technique that we've used. We just have to apply a slightly different processing methodology for it.
No worries. And a question from Stuart Mitchell from Virtual Taz. Do you have any other entities utilizing your software under license to provide a service to the customers?
Yep. So we've got a customer over in Singapore who's a contractor who owns their own radar unit. So they're using our service a little bit differently to kind of how I pitched it here. They're actually using our data processing services. So they upload raw files. We process all that for them. We visualize it in a visually nourishing way. And then they have access to the web portal, which they can view project by project. And so they use this platform for rallying behind with their stakeholders to undertake planning and coordination and also project design. So they're, whilst we haven't put any boots on the ground, they're over in Singapore mapping and providing the data through our service. And then we've got a couple of proof of concepts which we're currently in discussion with a couple of different, some of them asset owners in New Zealand and the US. And we've got another proof of concept for another city type solution over in Australia.
No worries. And a question from Derek. Are you matching the reveal asset ID with the actual asset owner's ID?
Yep. So that's kind of one of the tricky bits is to maintain the data heritage. So if the QLD or the existing records change, how can you actually replicate that same change into the model? And so we've done some smart stuff there to be able to match up those IDs, as well as to be able to track any changes that may come through from the asset owners themselves. But for anything that we've managed to, especially things like manholes and chambers, which are a lot easier to tie to existing asset records, you can start to pull together the asset ID. Don't know if it's exposed in this version, but it definitely is in the data model.
No worries. And a question from Caroline from Naviz. Who owns the data people upload to your platform? Which is, I think, a good question, actually.
Yeah, so the data ownership becomes the funny one, which some people are concerned about. So the information that gets provided is owned by that user. It's their information. And then beyond that, it really depends, based on the different, the commercial setup. So where we go out and proactively map a city, then that information is ours and we can commercialize that. And then depending on the different users we can make the information private if it needs to be private. But if it's willing to be shared, or if it's part of public entity and the asset owners is part of our membership program, then they can make that information publicly available. So it's kind of the information that's provided is owned by them. We then synthesize that and process and create some new insights for which we can then commercialize off the back end of. But again, it's not fixed. It's so we're working through it at the moment, and it seems to be it'll change depending on the commercial model. So for something like Wellington City, where it's a one customer and it's a city model, then essentially we don't own the data. There's one customer, which is Wellington City, but for other cities where we may do things proactively, it's kind of the opposite of that.
No worries, thank you. And the last question from Munawar, who's from Qatar. The success of the model seems to be largely dependent on voluntary information sharing and intimation by all stakeholders. This probably has an implication on policy and possibly on legislation to ensure all stakeholders contribute, i.e. mandatorily report any discoveries. Is there a proposal for such policy decision?
Yeah, so in New Zealand, there kind of is the mandate. There is a policy that exists which defines the obligations for the corridor manager and the utility owners to both update their records in a timely fashion, share their information, and also undertake work in an efficient manner. That's just in New Zealand, and so again that changes across the world. What we're hoping to do is to entice people to be able to use the platform that doesn't require mandates and policy changes. Otherwise, we'll be waiting around for too long before there's any real change. And so, an example of that is Collect, which is our as-builting app. So we've made it super fast and effective for a contractor to be able to capture their information in the field. So essentially we've productionized photogrammetry. And so we've made it so within, you expose a hole, you can walk around filming it, you upload it to our platform, we convert it into a photogrammetric model, we then extract all the utility information, and in return, you get your 3D as-built data to use in your as-building process, and we get access to some richer information so we can improve the model. And so the real, I guess, mentality that we've tried to do is trying to make it as intuitive and beneficial for all parties as possible, so that it drives kind of native uptake. If that doesn't work, then there's potentially alternatives we can look at, like financial rewards for people to provide information to the platform, or profit share, or things like that. So again, early in our journey, but we are kind of working through that.
No worries. And a question from Ron from Bentley. Since it is in a public space typically owned by government entities, is there any areas that you've had to sanitize, which, like Google Street Views and with car plates and registrations?
There were, a couple of examples. There is large pump stations which are locked and alarmed, which we shouldn't enter. But as long as you've got the go ahead from the various asset owners, which is the process we went through at the beginning to gain consent, then there hasn't been too many issues, to be honest, in the public road corridor. When you're working in private spaces, then it's a little bit different. So we do all the locating and utility survey for Transpower, which is the electrical network. So that works very differently. We do it in their substations. And we also service Auckland Airport. And again, that's another large private site with a whole different set of rules. And so the playing ground is quite different at those private sites, especially when there's large safety risks like very high voltage cables. And so that's why for this, what we've been focusing on has really been publicly accessible space with the road corridors, where people are free to access to provide the services that they need to.
Oh, someone's just joining now. And another question from Scott. Are you planning to collaborate with Build Media and the Wellington Digital Twin?
Yeah, so we have, so we're part of that, the Digital Twin program that Wellington City are running. And so under Sean Ordain and his team. And so again, we see ourselves as being that subsurface data solution. And so while we're not trying to replicate another city twin solution, we want to be that data set that can then feed into all the other city twins. And so how we can support anyone working in that space is super important for us. And so we see ourselves working probably the build media guys and whomever else. I think they've got 11 twins up and running. I'm not too sure what they entail, but if they need to understand the underground information, then we'll make our information accessible.
No worries. And another question from Derek. There appear to be a number of gaps between pipes or disconnected pipes. How much manual involved in enhancing the data captured by scans?
Yeah, so it's a really good observation. So and this is like a quick and easy kind of trick to understanding whether or not people will just visualize existing information in 3D and interpreted things, because kind of what we've created is an output of detections and information. So where we haven't got information to say otherwise, then we haven't inferred anything, and we haven't created a visual representation. And so this is quite different to like a connected network model or an asset register, because that's not the intent. The intent's not to be an asset register. We've got a 3D feature that represents everything on the, every record that you have in your asset management system. What this is telling you basically a risk-based approach to understanding what could potentially be in the underground. And it's just that first snapshot, using 5 or 6 different techniques. And so over time, it is likely that as people do trial holes, or they reinstate, or they repair or do renewals of new assets, that the gaps will start to fill in, the accuracy will reduce, the understanding of the unknowns will move from an unknown to a guess. And so things will change over time. And so what you're looking at here is kind of like a detections model. It's a representation of all of the information we currently have available. And so what that would mean is that there are gaps. And in the subsurface utility engineering space, what those gaps represent are what we refer to as unknown unknowns. They're things that you can't know about because you don't know about them. And so they represent kind of like a residual level of risk associated with projects, which is why you never just jump in and start digging with an excavator after you've done utility mapping, because there's always the risk that there could be unknown unknowns, things that you haven't been able to detect that don't exist on any plans. So yeah, a bit technical, nuanced, but it's important to, I guess, understand the difference between trying to create a visually nourishing 3D representation of existing plans versus kind of what we're trying to do, which is like a risk-based approach to understanding what's in the underground.
No worries. And a question from Hayden from Mud McDonald, which I think you might have already answered, but what software is used to author the model content?
To what, sorry? Author
the model content, yeah.
In the back end, in terms of data processing, we've got a bunch of workflow management software. There's some bespoke, data processing software that was used specific to the hardware. There's a whole heap of different stuff, and but the first sort of bit we went out to do was how we could wrap process around it, so that we could have a real consistent, repeatable process that would ensure a certain level of quality. So we've got this overarching kind of workflow management that allows us to be able to receive new records and process them in the right way, and understand every decision that was made along the way, so that the accuracy and the trustworthiness can be retained. But again, that's done using a whole heap of different techniques, and we kind of view that as being a bit of our secret sauce.
Cool, thanks. I think that's all the questions for now. Any other questions at all? Oh, we got one more. What metadata standard are you using? Which is a question from Chris Body from Canberra.
Muddy, MUDDI, which is an international open source utility data standard, which has been really good. It's a data standard and a data model, I think. But it's been really, it's fairly new from my understanding, but it's been really nice to work with something that's kind of already established in that space, and not have to recreate everything from scratch and just align with an international standard. And what we've seen is it's pretty comprehensive. It goes across not just utilities, but underground features and above ground features, and it's pretty easy. We've already mapped like the New Zealand's Waka Kotahi standard that came out recently for a subset of their assets. We've mapped their network to it. We've mapped 11 different asset owners in Wellington's asset registers to that schema. So we can start to push and pull information in a real consistent way, which has been hugely valuable, but yeah, muddy.
And I think Chris has just pointed out that it's an OGC standard.
Yeah. Yep.
And Derek just put a link for it as well. Thanks, Derek. Any other questions at all for Sam? No worries. Well, if there isn't any other questions, thanks everyone for joining. Special thanks to you, Sam, for answering all the questions in your presentation.
No worries.
And yeah, if there's any questions at all for Sam or myself regarding Smart Cities Council, feel free to reach out, and we'll see you at the next session.
Awesome. Thank you, everybody.
Thanks, guys. Catch you later.